Okay, so number 12 here in 4.7 is asking us to inscribe a rectangle inside of a right triangle, legs of 3 and 4. So we're obviously dealing with a 3, 4, 5 right triangle. There we go. And we want to maximize the area of that little pink rectangle that we have right there. Now, the way that I would handle this problem is to treat it like one of the area maximization problems that we did in our notes. And I would go ahead, and guys, this is a whole branch of math called coordinate geometry. And what I would go ahead and do is draw an x-axis and a y-axis right over here and try to realize here that it's a floating dot problem. We really just need to locate the coordinate of this point right over here. And we know that that point is located somewhere along this ray that I've drawn right over here. So what we're going to do is we're going to come up with the equation of that line there, the hypotenuse of the triangle. So I think that's the first key right here, guys. Y is equal to, all right, if I look at this line right here, my slope, we'd be going up 4 and then right 3, just using those values right there. So our slope of that line is going to be 4/3 times x, and our y-intercept is obviously going to be 0. So that's the equation then of this line that we have there. Y is equal to 4/3 x. And if you remember that cosine problem that we did in our notes, that equation right there, that's basically your parameter. This is step number 1. Whatever the relationship is between x and y at this point here, it has to follow this relationship. So what we're really doing here, guys, is looking for the coordinates of that point right over there, x comma y. Now, step 2 here is interesting. We're going to write an equation for the quantity that we're trying to optimize here. So we want to come up with, let's see, where did it go? We're trying to find the maximum area of that rectangle. So the area of a rectangle is obviously just going to be base times height, but this gets a little bit more interesting now as we try to use the coordinates of x and y to figure out the dimensions of that rectangle. I'm going to skip here and go to the y coordinate first. So if this point is xy, that means that from the origin, we're traveling x units to the right and y units up. Now that y can be transferred right over here if you wanted. Y is the height of the rectangle. Okay, so I'm going to put that in here for h. But coming up with the base of that rectangle is a lot more interesting. So what we know here, guys, is that x is the distance from here to here, and that 3 is the distance from the origin all the way over here to the right. So, let me switch colors on you guys here. If we needed to know the length of the base of that rectangle, it's going to be the whole quantity 3 minus this little piece on the right. So 3 minus x is going to give us the height, the base of that rectangle there. So that's really the tricky part of this problem right here, guys. It's 3 minus x. So what else can we do now to make this a little bit easier to work with? We know that the relationship between y and x is given right here. So this is a 3 minus x times a y value, which is 4/3 x, and I guess this is technically a of x now. And let's clean that up just a little bit by distributing here. So that 4/3 x is going to go backwards into here, and we're going to end up with a 4x minus, that looks like a 4/3 x squared. And that's an expression now that'll give us the area of that rectangle. And that is what we're trying to optimize. So moving on to step 3, we're going to take the derivative of that equation right there and get a 4 minus an 8/3 x. Yep, that's it. We're going to set that equal to 0 and solve. So 8/3 x is equal to 4. And just because this one's a little bit tricky, we'll multiply both sides by our reciprocal, which is 3/8. And that's going to get us x is equal to, oh, that cancels to make a 2 right there. X is equal to 3/2, which incidentally, you'll notice, is halfway between the origin, between the origin right here and that ending value of 3. So x is equal to 3/2 right here, and let me go back and read the problem again. They're asking for here, what is the maximum area of that rectangle there? So, a couple of ways I could go about with that. I'm going to go ahead and figure out, actually, you know what? No, I'm not. I'm going to use this formula that we came up with right here, I think, guys. That might be the easiest way to do that. Area, just using the x value, not needing y at all, is going to be 3 minus x times 4/3 x. So as I'm moving on to step 4, here we go. Area of that rectangle, when x is equal to 3/2, is equal to, in parentheses, that's going to be 3 minus 3/2, and that's going to get multiplied by 4/3 times an x value of 3/2 again. What does that do for us, guys? This is 3 minus 1.5. It's another 1.5, so that'll be 3/2 there. And when I go to multiply this, 3 on the bottom, 3 on the top cancel out, and I'm left with a 4/2, which makes 2. And now this 2 and that 2 cancel out, and we just ended up with 3 square units for the maximum possible area for that rectangle that we could get inside of that triangle. Okay, so that is number 12.